Hey everyone, this is an introduction to Target 8.1. Target 8.1 is about stoichiometry, which I will never ask you to spell or pronounce that, but in case you're wondering. So stoichiometry, this is Target 8.1, and stoichiometry is just sort of the culmination of pretty much everything we've been talking about all year, or at least semester. It's the idea that we can keep track of atoms. So I'm going to start off with what an example looks like and then how you'll go through this process. So a reaction that we did, and by the way, I am following the same exact example and from the notes. So if you look at the notes, you'll be able to see this is the example I use, but I just wanted to walk through them real fast. Um, when we're going to react, okay, so how many moles of HCl are required to fully react with 7.5 grams of zinc? I may have worded it a little bit differently in there, but that's the question. This is a reaction we did earlier in the year. Nope, you guys actually took the zinc and dissolved it in the acid, and it made little bubbles. HCl is the acid here, and we just want to know how much do you actually need. So the first thing you always have to do is you have to write out a balanced equation. So that's what I'm going to do. That's really why we spent the last few days writing out the whole balanced equation. So let's look at my equation here. I know I have to react with zinc. We're going to get HCl. I also know, and I would tell you this on a test or something, that we are going to end up making hydrogen gas and zinc chloride. So we'll add those two to there as well. So here's the equation. Solid zinc reacts with hydrogen chloride to produce hydrogen gas and zinc chloride. So we know that the zinc is solid. We know that the hydrogen chloride was a solution. We know that it made bubbles. Those are the hydrogen gas and the zinc chloride here. Now looking at this, this cannot be balanced, but it's not too hard to balance. Look, there's two chlorines right here. There's only one chlorine right here. So let's go ahead and I think we just need two of these. And then we're good. So far, this is nothing new. In fact, you've probably written out this reaction 2 or 3 times. Here's the new part. We are going to sort of simulate this reaction. We are going to imagine how this reaction must have happened. Now remember, we're big and all of these atoms are tiny, so we can't physically see this happening. So we're going to sort of mathematically pretend that we can. So what we're going to do is we're going to set up something called a BCA table. And a BCA table, and a BCA table, the B stands for before. Ooh, B, before. Ugh, let's just draw it like a normal size showing. B stands for before, C stands for change, and A stands for after. So we're just thinking about how many of each of these things we have before the reaction, how much is changing during the reaction, and how much is left over afterwards. Now a key point is this, is when we're using this number here, this 2 means that for 1 zinc, I need 2 HCl's. For 1 zinc, I get 1 hydrogen. For 1 zinc, I get 1 zinc chloride. That is what these coefficients mean. That's why we draw them out the way that we do. But what that tells us, though, is we cannot use mass in here. You see the 7.5 grams? 7.5 grams of zinc we don't know, this equation does not tell us how many hydrogen chlorides will react with that, because this is a mass, whereas these are counts. This equation right here is counting how many we'll need, how many we'll need, how many we'll need, how many need. One of these will react with two of these to make one of these and one of these. This mass will not do it. So a very major thing for you guys to know is the only thing that goes in this table is moles. Do not ever put a mass in here. If you put masses in here, it's just not going to work, because these numbers up here that we're going to use are counts, which means the only thing we can throw in here is a count. We've used moles for counts since Unit 5. So back to the beginning here. 7.5 grams of zinc. Well, we need to go ahead and convert that to moles. It's not too bad. 65.392 is the molar mass. So 65.392 grams. If we're going to actually go through and do the math here, remember we use a conversion factor. If we have 7.5 grams of zinc, but I don't want grams of zinc, I want moles of zinc. But I know that there's 65.392 grams per 1 mole of zinc. Grams of zinc will cancel out. We'll be left with I believe, if I remember correctly, 0.115 moles. Excuse me. So, looking here, this is the amount of zinc that we start with. So, before the reaction, we start with 0.115 moles of zinc. How much hydrogen do we start with? Well, remember, we're making hydrogen. So before the reaction, we don't have any. Same thing with the zinc chloride. Before the reaction, we don't have any. Now the HCl, we don't know how much we have. That's actually kind of what we're looking for. So we are going to use a symbol here that applies to whenever we know we have to have something, we just know that we have to have enough. I don't know how much HCl I have. I just know that I need enough. That's what excess stands for. It just means enough to get done what we need. Well, specifically means more than enough, but that's fine. So if you're ever given a problem and you know that you need something, but you don't know how much you have, feel free to put that thing in. Not every problem will have one of those. Not every problem will have some reactant where you just know you need some. We just know there has to be some there or else this reaction can't happen. If I give you a reaction, you know that there has to be HCl, just, okay, there's got to be some HCl or else this reaction isn't going to happen. And that's what this excess means. So this is what we have before the reaction. Before the reaction, we have 0.115 moles of zinc. We have more than enough HCl. We don't have any H2. We don't have any ZnCl2. Then the reaction is going to happen. And here's what I know, is one zinc will react with two HCl's to make one H2 and one ZnCl2. But we don't have one zinc, right? We have more than that. We have 0.115 mole. And remember, that seems like a small number, but mole is 600 billion trillion. So we're still talking about tens of billions of trillions of atoms here. So that's actually a huge number of atoms. But I'm going to react all of them. So we're going to take the Zn and we are going to react all of it, which means we're going to use it all up. The amount of zinc we have is going to all disappear. And after it's all changed, afterwards we are going to have none left. So we start off with 0.115 moles of zinc, but then we use up all of it, leaving us with none left over. Well, let's look at the other ones. So the hydrogen chloride here, we know that one zinc reacts with two hydrogen chlorides. So two zincs would react with four hydrogen chlorides. 10 zincs would react with 20 hydrogen chlorides. It doesn't really matter how many zincs I have, I will always need twice as many hydrogen chlorides. So if I have 0.115 moles of zinc, I need twice as many hydrogen chlorides. And if I remember correctly, twice is going to be 0.230 mole. So I don't know how much HCl I started with, but if I'm going to react all of this zinc, I have to use up 0.230 moles of it. I don't know how much I'm going to end up with, so I'm still going to use that symbol XS, but I do know exactly how much we had to use to get there. Finally, let's get these last two guys in here. These ones we are making. So notice how I marked these ones as negative? That's because the amount we have is going down. We are using up our zinc. These ones we're going to make. So these are going to both be positive values. We are going to gain hydrogen gas. Well, let's look up here at a reaction. If I have one zinc, I'll end up making one hydrogen. So if I have 2 zincs, I'll make 2 hydrogens. 30 zincs, I'll make 30 hydrogens. 10 billion zincs, I'll make 10 billion hydrogens. 0.115 zincs, 0.115 moles of zincs, and I should get 0.115 moles of hydrogen. Which means if I started off with none and made 0.115, I should end up with 0.115. Now the zinc chloride right here, same sort of situation, but you don't even have to go back here to the zinc. You can go look at just the hydrogen. See here, if I make one hydrogen, I have to make the same number of ZnCl2s. So if I make one hydrogen, I make one zinc chloride. If I make 10 hydrogens, I make 10 zinc chlorides. 1,000 hydrogens means I made 1,000 zinc chlorides. So if I make 0.115 moles of hydrogen, I have to make 0.115 moles of zinc chloride. So if we started off with none, made 0.115 moles, we must end up with 0.115 moles. This BCA table is now done. It has now been filled out. This is all the information we need. This should give us all the information we could possibly need about our reaction. So let's go back and look at our question and see what our answer will be. How many moles of HCl are required to fully react with 7.5 grams of zinc? So let's look here. The HCl is right here. So which one of these numbers tells me how much HCl I needed? Well, here the change row. If I'm going to react all of this zinc, I need this much HCl. 0.230 moles. If I don't have that much HCl, I cannot do this reaction completely. I can do a part of it, right? So I'm going to go ahead and say that this must be my answer. 0.230 moles of HCl are required. All right. So that is a basic BCA table problem. I'm going to expect to be able to construct your own table. I'm going to expect to be able to do all the math for your own table. I'm going to expect you to be able to fill it out, to populate it, and then I'm going to expect you to be able to pick out your answer from it. I'll try to keep things from getting too complicated here. For example, I'll probably always have, none left over of the reactants and stuff like that. But yeah, I think this is definitely doable for you guys. All right, one more quick note, and this is an important little item here. So I'm going to put this, I'm going to mention this real fast. You see this center row right here? I want you to compare it to the equation. The center row is always a multiple of the coefficients in the equation. Let me see what I mean. Let me show you what I mean. 1, 2, 1, 1. Do you see how these three are the same size? Okay, let's change to a different color. You see how these three coefficients are the same size? So the 1 for the zinc, the 1 for the H2, and the 1 for the ZnCl2, those three coefficients are the same coefficient. We'll look at our change row. 0.115 moles, 0.115 moles, 0.115 moles. Those three are the same as well. Well, look here at the HCl. See how that one's twice as big as that? Well, this is twice as big as that. The change row is always matching in proportion to your equation. Always. Just remember that on the left, those are things we're using up. The reactants, we're using those up, so those are negative. On the right, those are the products. They stay positive. All right, everyone. So this is just a quick example. Please do let me know if you have any questions. I'll be probably assigning our first example of this in the next coming day or two. This is it. This is the last thing. So get through this and you're set as far as I'm concerned. All right? All right, everyone. Let me know if you need anything. Talk to you later. Bye.